Hi guys, welcome to my YouTube channel. My name is Koforola and I'm so glad you can join me today on my channel and on this video today. My name is Kofo, like I said earlier, and I'm a data scientist, right? And on this channel you're going to see stuff related to me sharing my journey as a data scientist, from learning stuff and then working on project and everything in between. So that brings us to today's video. In this video today, I'm going to be walking guys through my latest project, which is the understanding flight delays in the United States. So I first came across this project on DataCamp, right? So the DataCamp competition, and I decided to just take it a step further and just expand a little bit more on the work, right? So that brings us to this video. And for this video, I decided to break it into the two parts, right? So for the first part, I'm going to be making a presentation style for the insight. So this is perfect for the non-tech audience, stakeholders, and also for the tech audience also. So I'm going to be sharing the insights with you guys from the Streamlit app, and then for the part two, I'm going to that deeper for the tech is right. So this part for the tech audience. I'm going to be walking guys through the data cleaning process, the model building, the EDA, all of those tech related stuff. I'm going to be walking guys through. So this is perfect for my tech audience. So stay tuned for part two coming up immediately after this video. Yes, so this kind of content is what you like. You're a techie, you're a data scientist, you're a data analyst, or are really interested in flight delays across the United States. Stick around, subscribe, like the video, leave a comment in the comment section, and share the video with your network, I guess. So without further delay, guys, let's explore the skies from a data perspective. This is the readme for the project, and then have all necessary information or details. Yeah, and you can go through. Let me know your thoughts. So moving on, let's start with Streamlit app page, right? So I have a link opened here already. So this is the welcome page for the Streamlit, and let's switch to presentation mode now. Flight delay prediction app. Welcome aboard the flight delay prediction app. Every year, nearly 1 in 5 flights around the world don't take off on time, costing the airline industry over 30 billion and throwing countless plans into chaos. Behind these frustrating delays lies a fascinating story, one told by data. In this project, you become the data detective and you journey through real world flight sleep patterns and discover the hidden factors that cause the delays from timing to routes and so many other factors. On the exploratory data analysis page, we dive into interactive visuals that bring the data to life and reveal surprising trends. Then step into the shoes of data scientists in the predictor section rather, where you use a powerful machine learning model to forecast whether a flight might be delayed. Your journey into the world of flight delay analytics starts now. Navigate through the sidebar and let the data tell its story. So moving on to the sidebar, starting with the EDA page. Welcome to the Flight Delay Explorer. Imagine planning a cross-country trip in 2023. Which airline should you trust to be on time? How often do flights actually get delayed? You might ask. We analyzed 327,346 flights across the United States throughout the entire year, uncovering real stories hidden behind the numbers. So, what's in the dataset, you ask? Our dataset captures flights from three major airports to 104 destinations, operated by 16 airlines over 12 months and all days of the week. And here is the overview of the key features. So how common are flight delays actually? And let's face it, delays actually happen, they do happen, they are inevitable. Or how often do they occur? Here is a quick reality check on departure and arrival delays, especially those that are 15 minutes or longer, which is the standard industry threshold for being late. So at for departure delays, we have a total of 39% of all flights delayed overall. So 39% of all flights did not take off at the exact scheduled time to take off. We see that 22% of flights were delayed 15 minutes and above our departure. For arrival, 41% were delayed. So 41% of flights did not arrive at their scheduled time of arrival. 24% of flights were delayed at arrival 50 minutes and above. So while most flights are punctual, roughly 1 in 4 flights face delays that can disrupt passenger plans. And this is what this project is all about, understanding the causes and recommending solutions. So these delays vary by season or day of the week, you would ask. Let's take a closer look at how delay rates shift across time in 2023. So flight delay often follow predictable time-based trend. We analyze delay rates by month, day of the week, and time of day to identify when disruptions are most and least likely to occur. These insights can help travelers plan smarter and support data-driven decisions in scheduling and operations for airports and airlines. So starting with the monthly delay trends, we observe a seasonal peak and dip across the year. How do delays shift throughout the year, you might ask? We see delay peak in summer, that is from June to July, and then in the holiday months in December. This is driven by high travel demand and weather related disruptions. So in the holidays, we can see there is winter, and the summer, we can see people are trying to go for vacations and all of that. So this causes spike in delays, right? Then in the 4 months from September rather to November, we see delay rates at the lowest. So this is thanks to calmer weather and lighter travel loads. During September and November, most people are just relaxing in their homes and there is not much traveling going on, and then the weather also is much better generally. So let's zoom in from the months to days of the week to uncover more timing based insights. Moving on to the weekly delay patterns, we see there is mid-week mayhem and the Thursday is the calmest. So which days of the week see the most or the least delays, you would ask? Tuesdays and Thursdays are the most delay prone, likely due to business travel surges and midweek congestion. So most business people tend to travel during Tuesdays and Wednesdays. Then Thursdays as the lowest and surprisingly very low delay rate. This actually offers a sweet spot before the weekend rush. So now let's drill down to hourly patterns. When in the day are delays are most likely, you would ask? We can see a steady climb in delay rates throughout the day and then peaking during evening hours from 6 p.m. to 12 a.m. So this tells us that early morning flights are the most reliable. So from 12 a.m. to 9 a.m., flights experience the least delay, and this is probably due to low traffic, rested crews, and clean schedules that all contribute. So, what is the summary recommendation so far? For travelers, your best bet for on-time flights, right? Book early departures, especially on Thursdays. Avoid evening flights and midweek peaks, that's on Tuesdays and Wednesdays, when delays are most likely to occur, and even on weekends, you will definitely get delayed. For airlines and airports, right, use these patterns or to optimize flight schedules, adjust staffing and streamline operations during high delay windows. Prioritizing early day efficiency and midweek resilience could greatly improve on-time performance and customer satisfaction. But when and how often delay occurs isn't the full story. Let's now explore how different airlines stack up in delay performance. Airline level performance. Who is on time? Which airlines are the champions of punctuality and which are the frequent offenders? We dug into flight performance across all carriers in the data set to uncover how often planes are delayed. Each airline's performance is visualized across 6 key slides: overall delay levels, the biggest offenders, the most punctual players, breakdown of delay types, that is the arrival versus the departure, then delay composition for worst performers, and delay composition for the most punctual players. Let's dive into the skies of data to see who is making passengers wait and who is keeping them moving. So, how do airlines compare in terms of delay? We can see there is a broad spread in delay rates across all of the carriers that we have, which reveals major operational differences. Identifying top and bottom performance helps spotlight reliability gap, and that's what we're going to be doing now. So let's focus on who exactly are the worst offenders when it comes to delays. So which carriers have the highest delay rates, you would ask? From the chart, we can see that Frontier Airlines, ExpressJet Airlines, Airtran Airways Corporation, and Mesa Airlines lead in delays with total delays rate above 60%. This pattern suggests persistent operational or route specific issues. But while some airlines struggles, others excel. Let's now highlight the most punctual carriers. Which airlines are consistently on time, you would ask? Hawaiian Airlines, Alaska Airlines, US Airways, and American Airlines maintain low delay rates at less than 40%. And this is probably due to less congested routes, efficient ground operations, and favorable scheduling. To understand the nature of these delays, let's break them down by type. That is the departure versus arrival. So how do airlines perform across departure versus arrival delays that are greater than or equal to 15 minutes, you'd ask? We can say some airlines tend to struggle more with arrival delays than departures or vice versa. And understanding where delay accumulates help identify bottlenecks, that is probably gate availability or boarding logistics. So let's zoom in further and see how the worst performing airlines stack up across these two delay types. The worst performing airlines struggle more with departure or arrival, should ask. From the chart, we can see that all four actually struggle with arrival delays greater than 50%. For Frontier and Airtran, we can see they have arrival delays greater than 55% at 57 and 56% respectively. This points to issues like turnaround inefficiency or destination airport constraints. For Mesa Airways Airlines rather and ExpressJet Airlines, they still have balanced but elevated arrival delays at 51% and 53%. Now let's flip the lens again and see how the most punctual airlines manage both types of delays. What kind of delays are most avoided by top performers, you would ask? We can see that Hawaiian Airlines leads with the lowest departure delay rate as 35% and the highest arrival delay rate as 65%. This is another pattern that we can see with the arrival delay being higher. US Airways follow with the departure delay rate of 40% and arrival delay rate of 60%. America and Alaska Airlines maintain relatively balanced delay patterns, though the arrival delay still exceeds 50%. So in summary, while top airlines perform better overall, arrival delay still remains a common challenge even among the most punctual carriers. Recommendation for improvement: benchmark operational practices of Hawaiian and US Airways, particularly in departure scheduling and turnaround management. Investigate persistent arrival delays, which could stem from external airport constraints or late inbound connections. Implement strategies to smoothen arrival, such as buffer scheduling or early departure leeway for high traffic routes. Airline performance tells part of the story, but geography plays a major role too. Let's explore which airports are driving the most delays at both departure and arrival ends. Airline level delays, where trouble takes off and lands. Are some airport magnets for delays? We analyze both departure and arrival delays by airport to uncover which hubs tends to cause or suffer the most disruption. So starting with the origin airport performance, how do New York City airport stack up? Three busy airports, one big question: who handle delays best? We looked at delay rates from Newark, JFK, and LaGuardia to compare how often flights take off and land late. What the data shows, we can see Newark tops the delay chart with 25% departure and 26% arrival delays out of 117,000 flights. JFK follows with 21% departure and 24% arrival delays with over 109,000 flights. LaGuardia is still slightly better but still challenged at 19% departure and 23% arrival delays across 101,000 flights. These airports operate in one of the most congested areas in the US, New York City, where weather, volume, and traffic control bottlenecks make delays a persistent issue. So, what should ask? For travelers, expect delays when flying out of New York City. So, you have to plan layovers with extra buffer time or leeway. For airports, there is room to improve ground operations and traffic conditions to ease schedule pressure. Let's now explore where flights are headed and how delay vary across destination airports. Destination airports delays. Destination airports tell a mixed story. Some struggle while others shine. We analyze delays across 104 destination airports to spot patterns in arrival and departure timeliness. What the data show, and this is an interactive chart by the way. So we can see that volume is not a major factor in delay, right? So while some flights with lower number of while some airports rather with lower number of flights like Jackson, Jackson O and then South Bend have number of flights at 21 and 10%. They still have high delay rate at 50%, 30%, 52% and 52% compared to flights like airports like DCA, Atlanta, Phoenix that have thousands of flights and lower delay rates. So we can what the data shows is that high delay regional airports like Jacksonville and South Bend face major delay challenges. Major hubs like Atlanta and Chicago who handle heavy traffic rather with fewer delays. Some airports stand out for exceptional punctuality like Salt Lake City and Seattle Tacoma despite varying flight trends. So what you'd ask? For passengers, regional airports can be surprisingly delay prone. Example, Jackson Hole and South Bend. Check your stats before booking connections. For operators, volume isn't the only factors. Infrastructure and planning plays a huge role in performance. With over 100 airports in the mix, patterns aren't always obvious. And to dive deeper, we clustered destination airports based on their characteristics and the results we're telling. Clustering destination airports. We grouped 104 destination airports based on departure delays, arrival delays, and flight volume to reveal distinct operational profiles. And for profile one, we have the cluster four, which is the very low delay, low traffic airports like Anchorage and Palm Spring that operate with minimal delay. So this is the chart for all of the airports. Moving to select cluster for the very low delay and low traffic airport. We can see the four of them: PSP, LEX, STC, and Anchorage. Yeah, Palm Springs and Anchorage that fall into that cluster. So this cluster, they have they have very low delay and they also have low traffic. So we can see the total flights are 508 for sort sort for Anchorage and for Palm Spring. For Palm Spring, you can see 18. For LEX, you can see just one flight. That was not delayed at all. So yeah. Then moving on to cluster one, which is the next one. Low delay, low delay average traffic airport like Chicago, O'Hare, and Fort Lauderdale. They handle moderate traffic with strong efficiency. So moving to examine that cluster, the cluster of low delay and average traffic. So we can see other ones, they have moderate traffic at less than 3,000, sorry, less than 5,000 flights majorly, and they still tend to handle traffic efficiently. Moving on to the next cluster, which is the low delay, high traffic hubs. So these airports tends to manage traffic efficiently despite having despite having high despite having high traffic, they still manage to handle delay delay efficiency. So we can see this cluster mostly have flights, total flights above 8,000. We can see 8,000 for DFW. We can see 9,000 for DTW. We can see Fort Lauderdale at 11,000. So these airports have actually mastered the art of being efficient at managing their high traffic and reducing delays for passengers, right? Then moving on to the next cluster, we have the moderate delay and low traffic airports. So these airports include South Bend and Birmingham, which face emerging operational challenge. They have moderate delay and they have low traffic and they still struggle with delay. So this have like you can see that they mostly have traffic less than 2,000 and they still struggle with high high delay rates. Moderate delay, let's just go with moderate delay from the cluster on right. So they still struggle moderate delay. Then for the final cluster, we have the high delay, low traffic. They represent airports that suffer from severe delays despite having low flight volume. So we have the CAE, the Jackson Obed, and the two TUL and OKC. So we can see that they have total flights less than 500 and they still struggle with high delay rates. So what you would ask, the least delayed airports often have low traffic but strong operational smoothness and busy hub with good infrastructure. That is the hubs that are mostly in clusters 3 keep delays despite high volumes. Smaller airports, moderate or high delays need targeted improvements. Airports in cluster 0 and cluster 2, they actually need targeted improvements to reduce disruption. Let's now shift our focus to the routes to uncover problematic origin destination pairs. So route level delay insights. Some routes are simply more delay prone than others, whether it's busy corridors between major or long haul routes affected by upstream issues. Certain city pairs rack up delays far more often than others. Let's explore which origin destination combinations are most impacted and which might be driving patterns. So for the route delay performance, this is also an interactive plotly chart. So the further to the top right a bubble is, the more problematic the route is, and bigger bubbles cause more flights. So we can see that the most problematic routes actually have lesser flight. I mean, this flight is less than 100, just 6, and they still struggle with delay. The ones with larger traffic still manage their delays efficiently. So moving on to the heat map for a quick glance of delay rates for the routes. We can see scanning through a column, we can see that the ones with the darker red have the higher delay. So we can see this one has a higher delay score rather of 39. CAE to Newark have 44, have the delay score of 44, while the rest still tend to like keep their delay rates below 10, 20, and all of that. So moving on to compare airlines on same route. So even on the same route, your experience may vary widely depending on the airline. So this route actually adds one airline. So let's look for another example of routes with more than one airline. Let's take this one for example. So on the JFK to TPA route, you can see that there are varying delay rates across different airlines. So for JetBlue Airways, JetBlue Airways has a total of 1,684 flights, and the delay rate for arrival is 25%. Sorry, departure is 25% and arrival is 30%, compared to Delta Airlines that manages delay rates at 16% and 14%. So we can see that even on the same route, your airline of choice still affects your delays. So moving on to the conclusion and actionable recommendation. After analyzing over 327,000 US flights of 2023, clear patterns emerged in how delays are shaped by timing, airline performance, and airport operations. And these findings offer actionable insights for travelers, airlines, and airport authorities. So we learned that delays spike in June to July and December, which is driven by the holidays and weather. And in contrast, 4 months and early mornings, that is 12 a.m. to 9 a.m., have the fewest delays. Tuesdays and Wednesdays are the worst days for traveling, and Thursdays tends to be the most reliable. So for recommendations, travelers fly on Thursday morning during off-peak season. During off-peak season, that is if possible. So fly Thursday mornings and avoid evening or midweek flights. Airlines try to work on adjusting your schedules around peak delay periods and strengthen your evening operations. Airline performance varies widely. We can see that Frontier, Express and Meta top the delay chart at 60%, while Hawaiian, Alaska and US Airways show strong on-time performance. And we know that arrival delays still remain a problem even for the top airlines. So recommendations are to benchmark top performance for top turnaround scheduling and address arrival inefficiency through buffer time and better ground handling. We also know that some airports are delay hotspots. So New York City airports are delay hotspots. If you are flying out of New York City, expect delay. And we also know that some airports face high delay despite handling low volume, example Jackson Hole, while some major hubs like Atlanta and Earth, despite handling very high volume, still perform well. And our clustering review over consistent under and over performance. What is the final takeaway? We know that flight delay follow clear patterns. They are not just chance events. So by understanding when, where, and why delay occurs, both travelers and industry players can take proactive steps to minimize disruptions and improve the flying experience. And that brings us to the end of the ADA section. So let's move on to the predictor page. So moving on to the predictor section of this Streamlit app, right? So on the sidebar here, we have the selector for that, and this is this predictor page that we are right on now. So this this is the interface where you input your flight details and then click on the predict delay button to get a prediction of whether your flight will be delayed or not 50 minutes and above at either departure, at both departure and arrival. So let's just try to go through some little demo and yeah, quickly. So let's just pick JetBlue Airways on, let's say Newark to Atlanta. Let's go with June, the month of June, on a Monday at, let's say at 1 p.m. right? So this is good. This is like the flight detail. So JetBlue Airways from Newark to Atlanta, the month of June, on a Monday at 1 p.m. So let's click on predict delay and see based on the model's prediction, this flight is going to be delayed 15 minutes and above at departure and at arrival. So whoever this flights whoever is going to be taking this flight, expect delay, right? So this is just a demo, right? But That's basically just how it works. So in future iterations and future versions, I plan to like integrate recommendations based on the predictions and the features that contributed to the predictions, right? So if it's a yes prediction, so which features contributed to the predictions being predicted as delayed, so that people can make smarter decisions. I feel like I should discuss this in the part two section, right? But let me just cover it here. It doesn't really matter. So that brings us to the end of this video. So be sure to go through the app yourself, check out the project on GitHub. Like I said, everything that you need, all details are on GitHub. So check out all information on GitHub and then let me know your thoughts and feedback in the comment section. And that's it from me, guys, and I hope you enjoyed the video. Don't forget to like, comment, subscribe, and share the video. Also let me know your thoughts and feedback and recommendations to improve the app, right? Yeah, so still I see you guys in the second part of this project video. That's it for now. Bye.